Okay, so what we're going to look at today is that sometimes it is actually not possible to factor a polynomial using one of our factoring methods or strategies. And so today we're going to see, well, how can we find a zero in that scenario? Normally what we did before in finding zeros part one is that we had all these different factoring methods at our fingertips. We figured out what would apply, we factored it, we set each factor equal to 0 and solved for x. And that's not going to be possible for us today. So a little something that I want to show you here in the first problem is that we're still going to think about replacing the y value with 0, so similar to how we did this before. But I just want to show you here why factoring is not going to work. So in this first problem here, notice how it does have 4 terms. And previously, when we had situations with 4 terms, we would try factor by grouping. Unless there's a greatest common factor that we see, factor by grouping is really the only other thing we can do when we have a polynomial of this size. So if we tried to take out the GCF from the first 2 terms, that would look something like this. So x squared out in front, multiplied by x plus 4 on the inside. But notice that the last 2 terms really don't have anything in common that we can factor out. We could try this because 1 is a factor of everything. However, even if we think about factoring out a 1, we're still left with an x minus 6 on the inside. And notice how these are not the same. And so we're not able to move forward with our method of factor by grouping. So we're only actually able to go forward to the next step if that parenthesis part is the same. There's no other factoring methods that we have that we can use. And so we're going to actually approach this a little differently using the help of a calculator graph. Now notice here that we're not seeing the full graph. We are just seeing a small picture of it. For all of the graphs we look at today, we are going to assume that the tick marks that we see represent 1 unit. And so because of that, we can identify that this looks like it has an x-intercept at positive 1. 1, 0 is passing through the x-axis. And we know that x-intercepts are also known as zeros. And so what this is telling us here is that we have a 0 at positive 1. That is one of our zeros. Now from the last finding 0 lesson, we talked about the fundamental theorem and that the number of zeros is equal to the degree of the polynomial. This one here has a degree of 3, and so in total, we should have 3 zeros. We just found one of them. We have a 0 at 1. That means that we have 2 more zeros that we need to find. So we are going to use a little bit of algebra to help us do that. It's just not going to be in the form of factoring. So if 1 is a 0, I'm going to make another little note off to the side here. This means that x minus 1 is a factor. So that was another little thing that we talked about a while back. It's called the factor theorem. That whatever the value of the 0 is, subtract that from x and put it in parentheses, and that's one of your factors. So if x minus 1 is a factor, and we want to find the other factors because we want to try to find the zeros, we are going to divide by x minus 1. And now that we know how to divide, we'll be able to finish out this problem. Now in this case, because we're just dividing by x minus a number, this is just a regular linear factor, we can use the process of synthetic division. You could do long division here, but you don't have to. We're going to do synthetic. It's just a lot of times a lot easier and faster if we're able to do it. So if we want to divide by x minus 1, we're going to start by turning that minus 1 into now what looks like a positive 1. A little number in the corner box is going to be the opposite sign of the number in parentheses of whatever we're dividing by. Let's go ahead and list out our coefficients. So going back to our polynomial at the very beginning, we can see that it's 1x to the third. We're just going to put a 1 there, followed by 4x squared, 1x, and then we have a negative 6 at the end. So anytime we have a subtraction sign, make sure you bring that down here and represent it as a negative. All right, now we're going to leave a little bit of space there where we're going to draw a horizontal line across the bottom. And our first coefficient is going to go straight down below the line. That 1 at the bottom is going to multiply by the 1 in the box. We are going to write the answer here underneath the 4. Add the numbers in this column to get 5. We'll do it again. The 5 at the bottom multiplies by the number in the box. 5 times 1 is 5. Add the numbers in the column here to get 6. Now that 6 on the bottom will multiply by the 1 in the box, and that turns into a positive 6. Move that up there. And so notice how that is giving us a remainder of 0. You must have a remainder of 0 when you are doing this, because we know for sure that this is one of our zeros according to the graph, and a remainder of 0 just means that what we divided by is a perfect factor. And so if you're doing this and you do not get a remainder of 0, go back and check your work. There could have been a mistake somewhere earlier on that you want to go back and fix. So let's just make a little note here that when we're doing this process, we must have a remainder of 0. Okay, so now let's look at the 1 and the 5 and the 6, and we're going to turn this back into a polynomial. So that just means we're going to put the x's back in, and it's going to be 1 degree less than what we started with. So we started with something that was x to the third, so we're going to turn this into an x squared polynomial, so 1x squared plus 5x plus 6. And what that result means is that if you were to take that and multiply that by the part that we divided by, this is going to equal the original polynomial that we started with. So actually, we now have kind of like a factored version of this, and we're going to actually see if we could maybe factor this a little bit further. So if we look at the trinomial part that we're left with, this is a basic trinomial. And if we look at the numbers here, they actually work out really nicely for us to factor this one step further. So we just have to find what multiplies to 6 and adds to 5. Let's do 2 and 3. Perfect. And so let's go ahead and fill in these parentheses here. X plus 2, x plus 3. Technically, we still have this x minus 1 at the very front. And we're going to say that that whole thing is equal to 0, which is what we're always looking for and thinking about when we're finding zeros. All right, so we weren't able to use a factoring method, but we have it factored down just by looking at a little piece of the graph and using synthetic division to help us. Now that we have it all the way factored, we'll continue finding the zeros the way that we always have. So we'll go ahead and set each piece equal to 0 and solve for x. We already knew that 1 was one of our zeros from our graph, but we still need to make sure we include it in our answer. And now we're seeing that we also have -2 and -3 to make up our full list of the 3 zeros that we're looking for. Well, let's take a look at our second problem. So this one is a degree of 3 again. We should get 3 zeros. And it has 4 terms again. Same situation as before. If you try to do factor by grouping here, it's not going to work. And so that's why we need to do something else instead. So looking at this calculator graph piece, we can see that it is passing through the x-axis at -2. So this is telling us that -2 is a 0. That's one of our zeros. We know that we still need to find 2 more. But because -2 is 0, that means that x plus 2 is a factor. And so for this problem, we're going to divide by x plus 2. All right, we'll do synthetic division again for this. If we're dividing by x plus 2, it's going to turn back into -2 when it goes in the little corner box. Kind of a fun fact for you when you're doing these is that whatever the actual x-intercept is, like in this case it's -2, that will always be the same as the actual number that goes in the box. Because you change the sign to turn it into this, and then you change the sign back. All right, we don't have any missing terms. We still want to look out for that. So we don't need any zeros. But let's go ahead and fill in. We've got a couple negative signs here that we don't want to miss. So we've got 1, -4, -1, and then 22 at the end. And let's go ahead and go through our synthetic division steps. So again, we're going to bring that first coefficient down to the very bottom. That 1 is going to multiply by the -2 in the box. We'll write the answer here, add the column to get -6. Multiply that by the -2 in the box, and we get +12. Add the numbers here to get 11, and then 11 times -2 is -22, which is exactly what we need, because we always want to make sure we have a remainder of 0 here. Now let's go ahead and rewrite this as the polynomial that it represents, which is really 1x squared minus 6x plus 11. And if we were to put that in parentheses, what's really happening is that if that multiplies by the x plus 2 that we just divided it by, that whole thing will equal the original polynomial that we started with. Now, if we look at the trinomial part, so kind of in the same position as we were in the last problem, in order to factor that further, we would have to find 2 numbers that multiply to -11 and add to -6. Not -11, +11, but then it would have to add to -6. We don't have many options here. We really just have 1 times 11. So this is going to be one of these. We're not able to factor the trinomial part. And that's okay. We can actually, just as we did previously, we'll just go ahead and set each of these equal to 0 right now as it is. So the first one is really easy to solve. We already know that -2 is a 0 from our graph. So that's our first answer. We just don't want to forget it. More work is going to need to be applied to this. So we know that if we can't solve the quadratic equation by factoring, this is where we're going to put it into the quadratic formula. All right, so we go through our steps here. X is going to be equal to, it starts with -b, so it's going to be minus -6, plus or minus the square root, b squared. And notice how we're using parentheses here around the -6 part. -6 squared, that's going to turn into +36. If you were to type it into a calculator, you would have to have the parentheses there just as you see it. And then we're subtracting 4 times a times c. So it's going to be 4 times 1 times 11. And all of that will be divided by 2 times a, which is really just going to be 2 times 1. so let's see how that starts to simplify. So it's going to turn into a positive 6 in front. Now, inside of our square root, we're doing 36 minus 44. And so it's going to go into the negative. It turns into negative 8. All right, now we need to think a little bit about how we can simplify that. So first off, we can see it's going to be imaginary. We're taking the square root of a negative. So we want to get that negative part out. It's going to turn into an I at the end. But we can also simplify the square root of 8 parts. And so this whole part, we'll just have the 6 stay the same, the 2 stay the same. What that part is going to turn into, I would think of it as square root 4 times square root 2. That's really the same thing as the square root of 8. And then we'll multiply by the square root of negative 1 at the end of it. So as long as these 3 elements here multiply the negative 8, we can split it up in that way. And then this is helpful because we can actually do the square root of 4 in front. It actually turns into regular 2. So that's 6 plus or minus 2 square root 2. The square root negative 1 is going to turn into an I at the end. And then the whole thing is still being divided by 2. And then this is one of those where we could actually go one more step. We can divide both parts of the top by 2 on the bottom. 6 divided by 2 is 3. And when you do this part here, it's only the 2 in the front that is dividing by the 2 on the bottom. And it's kind of like they're going to cancel out. So all we're left with is the square root of 2. You can put the I in front of the square root symbol, or you can put it at the end. But those would be the other 2 zeros right there. So one of them is really 3 plus square root 2i. The other one is 3 minus square root 2i. And then the real 0 that we had at the very beginning was that negative 2. Now remember that imaginary zeros, they don't show up as x-intercepts on the graph. So even if we were to have a more zoomed out version of that calculator graph, we're not going to see anything for those other 2. And we're still going to include them in our list of our final answer for getting the zeros. All right, so we just have one last problem that we're going to take a look at. And this one is a little bit different. At the very start, notice how it is x to the 4th. And so this means that we're going to have 4 zeros that we're looking for. There's definitely no way that we can factor this. When you get to having 5 terms, there's not a regular factoring method that'll work. Luckily, we do have this little screenshot of the calculator graph, but notice how we see 2 x-intercepts. And so this is actually telling us 2 of our zeros at negative 1 and negative 3. That means that we only have to find 2 more. We just have to find the other 2. Now, because we have 2 zeros visible, this means that we're actually going to go through the division process twice. So for the negative 1, we can divide our polynomial by x plus 1. And then for the negative 3, we can divide it by x plus 3. Now, the order of the division does not matter. I'm going to start by dividing by x plus 1, just because I have that one listed first. But you could do it in a different order. You're going to get to the same result. All right, so here's how that's going to start to look here. So if I'm dividing by x plus 1, we'll go ahead and turn that into a negative 1. Double check for missing terms, but it doesn't look like we have any. This one's also super nice because there's not any negative signs in that first line of numbers. We'll just go ahead and list them across. And we're going to go through our steps here of synthetic division. We got a remainder of 0, which is good. If I didn't get a remainder of 0 here, I'm going to go back and check to make sure that I haven't made a mistake. So that's good. Now, let's think about what this really represents. This is going to be a polynomial to the 3rd degree, 1x to the 3rd, plus 3x squared plus 4x plus 12. But rather than writing it out in terms of x, I know that I want to divide it by something else. And so we can actually do that right now. We can stack the division directly, one on top of the other. So we're going to take this polynomial answer and divide that by x plus 3. So what we can do is put our -3, the number in the little corner box, just put it right next to this 1 right here. And we're just going to go through this whole process one more time. We get a remainder of 0 again, which is good. So here's what I mean by the order doesn't matter. If you would have divided by x plus 3 first, and then take that answer and divide by x plus 1, the result right here at the bottom, it's going to be exactly the same. Now let's think about the degree of this down here. What we just had previously was x to the 3rd. So when we divided that again, now it's going to make it something that's x squared. So technically this is 1x squared plus 0x plus 4. And if we were to simplify that down, it's really just x squared plus 4. So all we need to do now to finish this is just to take that little x squared plus 4, set that equal to 0, and solve for x. We don't need to factor on this one. We can actually just use the square root method to solve. We saw a few like this already last week. If we subtract 4 from both sides, we end up getting that x squared is equal to -4. We'll go ahead and take the square root of both sides. If we think about splitting this up, it's really the square root of 4 multiplied by the square root of -1. When we introduce the square root symbol into the problem, we have to put the plus or minus sign out in front. So this is going to become plus or minus 2. And then the square root of -1 is I. So to finish this one out, if we were to think about our full list of 4 zeros, the 2 that we had from the graph were -3 and -1. And then we have positive 2i and negative 2i. So there's our list of 4. Again, on this one, even if we had our graph more zoomed out, we're not going to see any other x-intercepts because they ended up being a match.